Now moving on the setup process, open file, go to setup, go to G code generation. Here you need to check add tool change command. This one should be checked, and check do not switch on spindle. Then go to tool change command, tool change, click on perform tool change on TXM06, then finally empty spindle by loading tool number 0. This one also be checked. Now we need to select script for grabbing the pen and removing the pen. I will show you that. First delete this, we don't need that. Now to select the scripts, go to grbl plotter, look for data, go to scripts, then you will find two files, script pen select and script underscore pen remove. Now select the corresponding file to the corresponding table. Here is the tool table. Now how to set the tool table? Now to set up the pen changing mechanism, first we need to open grbl plotter, kill the alarm, and we need to home our machine. After homing, go to files, setup, tool table. Here you can see many tool numbers. You can add as much as tool you like. I have added 8 tools. Now we need to set the coordinates for each pen. Let me show you a G code. So this is a G code. Here you can see P01 M06. When this code appears in the code, the machine will perform a set of activities, set of sequence to change the pen. And if you remember, we have said this in the tool change menu, perform tool change on TX M06. So if you uncheck this, this line will not appear in the G code. Since we have checked this, each time this line appear in the G code, the machine will perform a tool change. Now what tool to change? T01. 01 means it needs to change to tool number 1. If this goes to T05, it will change to tool number 5, and that's it. And the machine remembers the previous tool change coordinates. So if say there is T01 and few lines later, say here is T02. So what it will do is, it will first remove the tool number 1. It will remove tool number 1 and then grab tool number 2. So this that's how it works. Now let's see what set of activities it performs. Open grbl plotter folder, go to data, then scripts. Here you will find script underscore pen2 underscore remove and select. These two files we have selected this here. So if you open these two files, this one for the selection and this one is for removal. First talk about the selection process. So these are the sequence written in G code to grab a tool. Now here you can see x hash t o ax, y hash t o ay. These are two variables that indicates each pen coordinates. I have used x and y coordinates, and I have a fixed value for z coordinates for all the pens. Only the x and y coordinates are changing. That's why I am using just two variables. But in your case, if you need to change the gripper height based on each pen, you can also use z hash t o a z, this variable. Now what are the values of this variable? Go to files, setup, in the tool table option you can see position x is 362.5. so when where it goes, yes, there. So in the G code, when T01 command appears, it will perform these set of activities. These 12 line, it will run in a sequence. So first what it will first adjust the gripper height. Then it will set x and y axis to the corresponding coordinates. For example, if I want to choose tool number 1, first it will set the gripper height at 22, then it will set x at 362.5 and y 6.5. So how to replicate this? We can actually replicate this. So let me show you. Let's rehome the machine. And this is the command prompt. You can jog using the jog controller here, or you can type G code. For example, if I type G90 all in capital letters, G90 x 100, that means it will move x to 100 millimeter from the machine using the machine coordinates. So you can see the x is moving. Now if I want to move it faster, I can put G0, which is in rapid acceleration, and I want to move x to back again into 0, moving back into the 0. If I want to move x and y at the same time, I can put x 100 and y 100. It will move x and y together. Now if I want a relative position, I can type G91 x 2 y 2. Before sending this, look at this tool coordinates. Here x is 100, y is 100, and just forget about z. So x is 100 millimeter in positive direction from the machine coordinate, machine 0 position, and y is the same. Now if I put if I go G91, which is relative position, and click send, it will move 2 millimeter away from where it is, 2 millimeter in positive direction, since x is 2. Now if I want to go back 2 millimeter, I simply just put x minus 2, y minus 2, again into, it is again back into 100. So G91 is relative motion and G90 is absolute measurement based on machine coordinates. So these two terms you need to keep in mind. Now let's go to our sequence. First we have G90, G53. G53 also indicates machine coordinates. Just copy it, and if I paste it here, the Z height is set. Next is we need to set X and Y coordinates. So first copy it. Since we are using the command center, we can put just variables here. We need to put actual values here. So what is the values for selecting the number 1 pen? This is X is 362.5. So just put it here. X 362.5 and Y is 6.5. Let me put here and hit send. Now the gripper is in front of the pen. Now we need to open the gripper first. So to do this, type M3 space S160. Now the gripper is open. Now we will switch to relative motion. There we will switch to relative motion. G91. Now we will move X to 25 mm in a positive direction. X 25. Now you can see the pen is positioned. Now we just need to move the Y in the positive direction, which is 5.5 mm. So just type Y 5.5. Now the pen is inside the gripper. Now we just need to close the gripper. So type M3 S50. Now the gripper is closed. One short note here: don't make the gripper too tight. If you make this too tight, sometimes the servo may jam. So I initially tried S0. I thought it will be a stronger grip, but when the machine plots for about 1 hour and 2 hours, and after that it needs to change the pen, the gripper doesn't open because the servo physically jammed inside. So just make sure the grip is firm enough just to hold the pen, not too tight, not too loose. For my case, S50 is standard tight. Now we need to move up the pen from the holder, from the pen holder. So to do this, type Z12. Now the height is correct. It is at the safe height to move away from the holder. We will go back to the absolute positioning. So I am typing G90 X 360. Now it is free from the pen holder. So this is the sequence I have set up for selecting the pen. Now if you ask how I get the coordinates for each pen, now let me show you. Now to find out each pen coordinates, which we will put in the tool table, first let me set the pen gripper height. I am just copying it. The gripper height is based on trial and error. For me Z22 works fine. If you keep the gripper at too much height, the pen may not touch on the paper. So you need to give a few trial to see at which height it works best. And if you set even if you set the gripper at too high, it may not insert into the pen holder. So there is a couple of trial and error required. So now my gripper height is set. Now we need to open the gripper. So for this I am typing M3 S160. Now the gripper is open. Now I will jog the machine to actually grab the pen. So I am just going relative position. first x2. I'm showing I need to move y in the negative direction, so typing y minus 1, again x1, now I think x is at the perfect distance to grab the pen. Now I just need to move y in the positive direction. So again I am going small steps, 0.5 millimeter each time in the positive direction. There is a little room. I think that's enough to show the pen is perfectly touched to the gripper, and I can actually rotate the pen. It is free but perfectly touched to the gripper. So this is the perfect position I want to grab the pen. So now what I will do is do some maths. If you look at the sequence, the y moves 5.5 millimeter in the positive direction to grip the pen. So to find the tool table coordinates for y, I will just minus 5.5 from where my y is actually right now. So my y is actually at 12 millimeter in absolute machine coordinates. So I will minus 12 minus 5.5, hence I will get 6.5, and this value I have put it in the tool table for tool number 1. And for the y, you can see the sequence there. The y moves 25 millimeter in positive direction to grab the pen. So I will just minus 25. So where I am right now, I am right now at 387.5 millimeter in absolute machine coordinates. So I will minus 25 from 387.5. I get 362.5. So I put 362.5 here. So that's how it works. You need to do this for each pen individually. You can also put offset here, but since my pen holder is completely handmade, so the offset doesn't work. There is a plus minus 1 millimeter up and down, so I can use offset. You can see I have used 362.5 for pen number 1, and if you go to pen number 7, it is 360.5. So there is 1.5 millimeter and 1 millimeter, sometimes 0.5 millimeter above and there, because it is handmade. But if you use 3D printer, you can actually use offset. It will reduce your pen setup timing. Since I can't use offset, I have to individually set the coordinates for 8 pens. But if you know the right distance from each pen to another, you can actually use the offset. It will actually reduce your workload. Now to remove the pen, I will go to the pen remove sequence. First we have to set the correct gripper height and just copy paste it. Now again we will switch to absolute machine positioning, type 362.5 and y is 6.5. Now what? Now we need to position. Now we will go to relative positioning and move y 5.5 millimeter in the positive direction. Now the pen is perfectly parallel to the holder. Now we just need to move x-axis in positive direction 25 millimeter. So I'm just typing X25. You see the pen is perfectly positioned in the pen holder. Now we'll just lower the gripper a bit and then open the gripper. So I am tapping Z-10, just enough lowered. Now we will open the gripper M3 S160. Then to get out we will move Y the negative direction 5 millimeter. You can see the pen just drops in there and perfectly sits in the holder. Now it's free to move the x-axis. So I am just going again into the absolute machine positioning, and we will go to 360 millimeter away from the machine coordinates, or where we have set our 0, which is at the homing position. Hit enter, it goes. Now another interesting thing I would like to show. The pen holder is not perfectly perpendicular, nor the pen gripper. Why this is? Because you never put a pen at perfectly 90-degree angle. It will fall, and there is machine vibration there, so it will never stay in there at perfectly perpendicular. So the pen holder is at an angle. I don't know you can see it or not. The pen is not perfectly perpendicular. I'm not sure how to show it. It just slightly angled, so it just stays there, not fall. And the gripper itself is at an angle, so it grips the pen at an angle and removes the pen at an angle, so the pen doesn't fall. If you make the holder perfectly 90-degree, there is a high chance the pen will fall like this. With this, the setup process is complete. Now let's run a simple G-code to see if everything works fine. First open up grbl. Kill the alarm. Power the machine. First home. Now we'll try to create a simple G-code. Let's start with creating a simple text. So go to G-code generation tab, click create text. You can type anything you want, test 1 for example, and you can select which tool to choose. Since we have only set up tool number 1, select tool number 1. You can set the height and width of the text. You can select font. You can use any font you like. I'm just keeping it as default. Just create G-code. So this is our G-code. It is showing it will take 22 seconds to complete the full process, and it will move X to a maximum of 118 millimeter and Y to 33.31 millimeter. I have loaded a pen in the slot 1. Now just press start streaming. The noise is from the fan. The controller gets very much hot, so you need to cool them down. and it successfully finishes the plotting.